Good evening, all. Am I audible?
Yes, sir.
Okay. All right. So let's start with the next topic: tangent and normal. So, what we are going to study in this topic, we are going to study how to find slope of tangent at a given point of a curve. Okay. How to find the slope of normal at that point of the curve, and how to write their equation, and what are the application of tangent and normals. And ultimately, dy by dx is in use. So once again, it is application of derivative or dy by dx. So let us say there is any point P on any differentiable curve. So I have drawn some random curve y is equal to fx. It is continuous and differentiable. Let us say we have a point P x1 comma y1 on this curve, and suppose I draw a tangent. Okay. So two questions can be asked on this. One is, what is the slope of this tangent? That is very easy to calculate. That is dy by dx. And then you put x1 y1 in place of x and y. And second one is the slope of normal at the point. So here, now we all know what is normal. In coordinate geometry also you have learned tangent and normal, equation of tangent normal to circle, parabola, ellipse, hyperbola, etc. So normal is basically a line which is perpendicular to the tangent at the point of contact. See, there can be infinite lines which may be perpendicular to the tangent. I can draw several parallel lines parallel to this red line. Okay, but not all lines will be normal because tangent is drawn at x1 y1. So at that point, if we draw a line perpendicular to tangent, it is called normal. So firstly, some basic points to discuss. What they can ask you, they can ask you to find the slope of tangent. Okay, slope of tangent at x1 y1. Obviously now this equation will be given. So answer will be dy by dx at which point? At x1 y1. So you will differentiate the function and you will put x and x1 y1 in place of x1 and y1, right? Now secondly, slope of normal. Slope of normal at this point. Can anyone tell me how you will find the slope of normal here? What is the concept that you can use? Because see, you have the slope of tangent from the first formula. So can you make use of it to get the slope of normal? Do you remember anything from class 11th?
Some minus 1 upon slope of tangent.
Yes, correct. See, so basically this result in class 11th you have studied that if two lines are perpendicular, right? If two lines are perpendicular, the product of their slopes is minus 1, right? M1, M2 equals minus 1. So here, since normal is perpendicular to tangent, so the product of their slopes will be minus 1, and M1 is like dy by dx, right? M1 means slope of tangent. So dy by dx into M2 is minus 1. So what about M2? It will be minus 1 upon dy by dx. Okay. So if you get the slope of tangent, you take the reciprocal of it and put a minus sign, you will get slope of normal. In other words, this can be written like this also. Why? Because in first derivative there is like, it can be treated as fraction. Okay. So dy by dx is reciprocal of dx by dy. This we have already studied. Now related to these two, equation of tangent at this point. So now it is easy because if anyone knows how to write the equation of line, because tangent and normal are ultimately lines, right? So if we have to write equation of tangent to this curve at a given point, then it is very easy. Why? Because it can be written in the form of y minus y1 equals m into x minus x1. That is slope point form. So point on the curve is this. That will be the point on the tangent as well. And in place of m, we put dy by dx. Okay. So let me add in here only. I'm not writing the sentence every time. So this is your equation of tangent. Okay. Now equation of normal. So again using point form, because point is x1 y1 only. So here I can write minus 1 upon dy by dx into x minus x1. So in this way you have learned four things till now. Slope of tangent, slope of normal, equation of tangent and equation of normal. Okay. Once you know dy by dx, you can calculate anything. One important point which is quite obvious from the graph itself, that the point x1 y1. Okay. Though it is easy to understand, but you should remember when you are solving the question that point x1 y1 lies on the curve, tangent and normal. This is basically the point of contact, right? So this particular point, this P point, it should lie on all the three. This is another important point that you need to remember, because we will be using this fact so many times that this point lies on this curve, so it will satisfy its equation. Okay, we will use this. Now based on this we'll solve some questions, but before that there are some more points to be discussed. We can continue here only. So there are some points to be remembered. Suppose if the tangent at x1 y1 is parallel to x-axis. If tangent at x1 y1 is parallel to x-axis. So what you can say about dy by dx? See, if the tangent is parallel to x-axis, and if two lines are parallel, their slopes are equal. So if you remember, we measure angle starting from x-axis only. So x-axis make 0 degree with itself. So its slope is 0. Slope is tan theta. And if line is parallel to it, so its slope will also be 0. So any line which is parallel to x-axis, its slope will be 0. If the tangent is perpendicular, tangent at x1 y1 is perpendicular to x-axis, or I can say it's parallel to y-axis. Both are same things. Now can you tell me what such condition? Just like if tangent is parallel to x-axis, dy by dx is 0. So what similar kind of condition will be coming here? Can anyone tell me? If tangent is perpendicular to x-axis or parallel to y-axis, then what is the condition? Yes, anyone?
So dy by dx is equal to infinity.
Yes, so dy by dx equal to infinity, but see, we never solve anything like equal to infinity. So if dy by dx is infinity, it is better to say dx by dy is 0, right? Because you never solve equation like x square plus 2x equal to infinity. What is x? Okay. But you have solved many equations where like there is 0 on the right hand side. So instead of saying infinity, say dx upon dy is 0. Actually, both are same things. Dy by dx becomes infinite, its reciprocal will become 0. But when you'll be solving the question, so this kind of formula will help you not equal to infinity. Okay. Then the third point. So if the tangent to the curve y equals fx, this is repeating every time this sentence, no? Tangent to the curve y equal to fx at x1 y1. makes equal intercepts with the coordinate axis. With the coordinate axis, plural form. That means with both the axes, the tangent is making equal intercept. Intercept. Okay. You remember intercept form of line, slope intercept form, or intercept form of line x by a plus y by b equal to 1, something like that. So they are saying that whatever that tangent is, that is making equal intercept with the coordinate axis. So in such case, what about dy by dx? Can anyone tell me? Forget about tangent. Just think about one basic thing. If a line is making equal intercept with both the coordinate axes, can you tell me what will be its slope? Any line making equal intercept with both the coordinate axes, what about the slope of this line? Is it any particular value?
1.
Think once more time. Yes. If I'm not wrong, you said -1. See, if you remember, this used to be intercept form of line x by a plus y by equal to 1. If b becomes equal to a, if b becomes equal to a, then x plus y is equal to a, y equals minus x plus a. What do you think? What is the slope? -1. So tangent is what? Tangent is line. Tangent is line. Line is making equal intercept with the coordinate axis. What about its slope? -1, not 1. Okay. And if you remember, in intercepts you have to consider two things, magnitude and direction. See this, I can treat this as equal intercept. Why? Because both of them have same magnitude. X and y intercept, both of them have same magnitude, and the directions are also positive. But I cannot say that this is like, I will not say they are equal intercepts. Why? Because one of them is cutting in positive direction, other one is cutting in negative direction. So in case of intercept, we need to consider magnitude as well as direction. So just by coordinate geometry, I can say that whenever a line is making equal intercept, its slope is -1. And slope is what? Dy by dx. So remember this important point. Finally, the last point here. If the tangent to the curve make is equally inclined, tangent to the curve y equals fx at x1, y1. See, actually these statements come as it is in the question. So they will say that if this is making equal intercept. So quickly you can understand that dy by dx is -1. Okay. So tangent to the curve at x1, y1 is equally inclined to both the coordinate axes. Is equally inclined, or let me use the plural form, to the coordinate axis. Okay, the plural form. Then dy by dx equals. Now can anyone tell me what will be the answer? Every time we are just getting some particular value of dy by dx. What about this case? Equally inclined to the coordinate axis, tangent, which is a line actually. Now what about dy by dx? Yes, anyone? What is the meaning of equally inclined? That means the line is making equal angle with the coordinate axis. Look here. I can consider this line, and equally inclined means it makes 45-degree with y-axis, 45-degree with x-axis. But in such case, listen carefully. In such case, this is the inclination of the line. Inclination is always taken from positive direction of x-axis in anti-clockwise sense. So what is your slope in such case? If line is like this, what will be slope? -1. So it looks like that dy by dx will be -1. But line can be drawn like this also. This can be 45. this can be 45. Okay, again equally inclined, but here this angle will be actually acting as the inclination also. So in such case m will be 1045 degree, that is 1. So ultimately tangent to the curve y is equal to x fx at x1 y1 is equally inclined to the coordinate axis, then dy by dx is your plus minus 1. Okay, both are possible. So remember these 4 points. Okay, tangent is parallel to x axis, dy by dx 0. Tangent parallel to y axis, dx by dy 0. Tangent makes equal intercept with coordinate axis, slope is minus 1. Tangent is equally inclined to coordinate axis, slope is plus minus 1. So these points will help you in solving the questions. Okay, let's start the problem solving. It is not over, okay? Don't think that it is over. Now every topic will be of 2 classes, okay? Tangent normal 2 classes, monotonicity 2 and maximum 2. So this is just the first half. And it will be better if you solve these questions and tell me the answers, because basic questions, so all of you must solve them. Find the slope of tangent. Find the slope of tangent to the curve, because at one point you can draw only one tangent. That's why. So there is this some random curve. Okay. To find the slope of tangent, you need not to draw the graph. Okay. You have the formula. Use it. So this is the first question. Tell me what is the answer of the first question. This. Yes. What is the answer of the first question? Yes. First question. So what you need to do in first question? You need to just differentiate. Why so much time? Slope of tangent is your dy by dx, no? And the point of contact is 1 1. So just differentiate it. And to differentiate here, it is implicit form, right? You cannot separate x and y. So basically you will have to divide both sides. So d by dx of x cube plus 3xy plus y cube, d by dx of 5. Okay, basically differentiate both sides with respect to x. First part 3x square. Second part you have to use product rule along with chain rule. Let us take 3 outside. So differentiation of x is 1, y is constant. Differentiation of y is dy by dx, x is constant. Then differentiation of y cube is 3y square. Then use chain rule, dy by dx equal to 0. Now simply put 1 1 in place of x and y. So 3 plus, I am putting 1 1 in place of x and y everywhere. So I think minus 1 will be the answer. Because 3 divided by dx, 3 divided by dx is 6 divided by dx, and 3 plus 3 is 6, so minus 6 divided by dx is minus 1. This is the answer of the first question. Simply differentiate and put the value there. Now try solve second question. Find the point on this curve for which tangent is parallel to this line. Note down both the questions, second and third, and then try them. Okay, can anyone tell me what you will be doing in second question? Forget the calculation part. Find the point on this curve at which tangent is parallel to the line this. How to use this thing?
So we
Yes.
can equate the slope dy by dx is equal to the slope of y is equal to 3x minus 2.
Which is 3, right? Because line is of the form y equals mx plus c. This line, compare it with y equal to mx plus c. Coefficient of x is your slope and this is your y intercept. But let's concentrate on slope only. So what we will do, we will differentiate this curve and we will equate it to 3. Why? Because if tangent is parallel, slopes will be same. Concept of coordinate geometry, two lines are parallel, m1 equals m2. So in second question, y equals x cube minus 2x square minus x. So dy by dx is 3x square minus 4x minus 1. This implies 3x square minus 4x minus 1 equals 3. Reason, slopes are equal. Tangent is parallel to that line. Two lines are equal. Sorry, two lines are parallel. Slopes will be equal. So this is quadratic. I'm not telling you how to solve quadratic. I will write the values 2 and minus 2 by 3. Okay, these are the values of x. You have to basically find the points on which tangents drawn are parallel to this line. So what you will do, you have the x coordinate, you need y coordinate, use curve and you will get the answer. So basically point of contact lies on the curve. When x is 2, you put x equal to 2 here, 8 minus 2. So you get minus 2. This is 1 point. So basically 2 points are coming. That means there will be, because the question is find the point on the curve at which tangent is parallel to the line. So that means there are 2 points at which when we are drawing the tangents, they are becoming parallel to this line. Okay. Another point, when you take x is minus 2 by 3 and put this x coordinate in this curve, okay, you will get some y. Okay, that is not important what exactly you will get. Maybe this. Okay, check yourself later on. So this is the second point. So direct application, right? Dy by dx. Now solve the third one. Third question. And all these questions are in your like notes that I have shared. Okay. So solution, everything is written. Just concentrate on the practice part here. Okay, so what is the meaning? What is the meaning by this term? Vertical tangent means what? Point. Find the point on this curve for which the tangent is vertical. What is the meaning of this term? Tangent. Vertical tangent means. Curve is this. Find point on this curve for which when we draw tangent on that curve a point, it is vertical. So y minus e to the power xy plus x. Yes, who can tell me about dy by dx?
So dx by dy is equal to 0.
Yes, correct. Because see, vertical tangent means basically you are drawing something. It may be any curve. I don't know what that curve is. We are not interested in drawing this graph. Okay. Let us say it is something like this. Maybe. Let's say it is like this. Then this will be your tangent. Okay. Vertical tangent means perpendicular to x-axis, parallel to y-axis. You need not to think anything about it. Just put dx by dy equal to 0. But what you will be actually doing? You will be finding dy by dx. Then you take the reciprocal of it, put it equal to 0, get the point which satisfy that equation. Alright, so dy by dx. With the help of this question, I will tell you one important thing. Okay, so dy by dx minus. Here we will use chain rule. Okay, so differentiation of e to the power anything is e to the power. Then into, now we will differentiate x into y. Taking x as constant differentiation of y, taking y as constant differentiation of x, then differentiation of x from here, that is 1. Okay, so let us collect the terms having dy by dx. It is dy by dx into 1 minus x into e to the power xy. Then this term minus y into e to the power xy plus 1. We will shift these two terms without dy by dx on the right hand side. So y e xy minus 1. I'm talking about these two terms. And then whatever was present with dy by dx, that will come in denominator. From here I will find dx upon dy, which is the reciprocal of it, and now I'm going to put it 0 because of vertical tangent thing, right? There now dx by dy is 0, vertical tangent. So basically this will become 1 minus, what will happen when you put something equal to 0, it is in numerator upon denominator form. So what will happen? Denominator will shift to 0. You will be left with this. Okay. So 1 equals x e to the power xy. Now the problem is they want you to find the point of contact from here. Okay. They want you to find point of contact from here. So basically, whatever that point of contact is, this point x1 y1. Okay, it will be lying on tangent as well as the curve. So it will satisfy this equation. First one, the curve, and it will also satisfy this equation also. Why? Because dx by dy is 0 at x1 y1 only, right? So now 1 equals x e to the power xy, and another equation was this. So even it is very difficult, it is very difficult to get rid of y from here. If you think you will be able to solve them, it's not going to happen. Like for example, you may think I will substitute value of e to the power xy. E to the power xy is 1 by x. You put it here. What will happen? Nothing. It will be something like this. Now you will think I will replace y. For that you may take log here. Ultimately, sometimes either exponential question will be form will be there or logarithmic form will be occurring. You won't be able to solve it. Then what to do? I have written solve them. How? By observation. By observation, you are supposed to tell me what is x and y. Because see, if this question comes in your objective exam, you can even put the values. Boards, it's not going to come. Forget about it. So if you have to observe, can you tell me what are those values of x and y which satisfy both the equations? And whenever we are supposed to observe, things are not very difficult. Just like in cubic equation, you find one root by hit and trial. Okay. So can you tell me what are those values of x and y which satisfy these two equations?
1, 0.
Yes, correct. So it is that easy. X1, Y0. You put x equal to 1 and y equal to 0 in first equation, 1 equals 1 because e to the power 0 will be 1. Similarly, you put these values here, they will also be satisfied. So you know what is this 1 comma 0. This is your point on which you draw the tangent and it is vertical tangent. So sometimes you may have to observe because if you will try to solve them, no, you will try to eliminate one variable and then change everything in terms of simply x or y. It won't become that equation which you are able to solve. It will contain terms of log x. There will be x also. It is possibility that there may be a term of e to the power x as well. Okay, you won't be able to solve it. And since they want the coordinates, so then obviously hit and trial is left. So not every question can be solved by observation, but see, the point is so simple. So at least we can think about it. Next question. If the line ax plus by plus c equal to 0 where abc are non-zero, abc not equal to 0. And this line is normal to the curve. This line is normal to the curve xy plus 5 equals 0. Then find the possible signs of a and b. A and b. Now we have to use this fact that this line is normal to the curve. Okay, xy plus 5 equal to 0. So what we will do, this is your curve xy minus 5 and we can write it like this also. It is rectangular hyperbola if you remember. So given curve is this. You simplify it, you get this. Okay. Now from here you will find dy by dx, that will be a 5 by x square. If you want, you can write at x1 y1. If you don't want, it is fine. You can write simply in terms of x only. So this is your slope of tangent. So from here, what will be slope of normal? Since m1 m2 is minus 1. Okay. So it will be the reciprocal and then we put a negative sign. So this is slope of normal. And now you can equate this to minus a by b. Why? Because if you remember in class 11th you might have studied the chapter straight line. There you learn to find the slope of the line using slope of line from general form. It is minus coefficient of x upon coefficient of y. If you don't know that form, then what you can do? First you can shift terms of x and constant to the right hand side and then you divide both sides by b. So ultimately it will change to the form y equals mx plus c. From there also the slope is minus a by b. So I have got the slope of line as minus a by b and I have also the slope of the same line as minus x square by 5 because it is also slope of normal by calculus. This is slope of normal by coordinate geometry, but both of them are same line, so we'll equate them. From here I will get x square upon 5 as a by b, and on the LHS it is clearly positive value. LHS is x square upon 5, so obviously it is positive. So a by b is positive, and if a by b is positive, This implies A and B are of same sign. Because if division of two numbers is positive, then either both of them are positive or both of them are negative. This is the concept to be used here. I hope I'm clear. Okay, let us take the next example. Find equation of normal. I want you to try it first. I want an answer. Find equation of normal drawn from the point 1 comma 2 to the parabola. I will give you options also. To the parabola x square equals 4y. Okay, this is the question. Try this question. I'm giving the options. These are the options. Can anyone tell me how you will solve this equation? How you will get the equation of normal? Yes, anyone?
So is
Uh, are you getting option A as the answer?
yes, sir.
See, there is one problem with this option. Can you tell me what is that problem, or anyone else? When you will be getting a option? See, let me draw this parabola first. X square equals 4y. If you look at the question, if you look at the question, it is said that you have to find the equation of normal drawn from the point 1 comma 2. Drawn from the point. The point is not your point of contact. Okay. This is the mistake that we usually do. And obviously, according to the mistake, wrong option is always given. So if you take 1 comma 2 on the curve, but why you did that? It is not satisfying this equation. Is 1 comma 2 satisfying this? No. Then if you took this as point of contact only, then you will be getting the option A. The question clearly indicates that you have to find the equation of normal which will be drawn from this point. Okay. Not at the point, from the point. Okay. Note the difference. I have not taken even a single question where you are simply value putting. Just the first question where we calculated slope of tangent. Now you'll learn something. Okay. Just value putting, you won't learn anything. So 1 comma 2. So we don't have this point of contact, right? Let us say it is x1 y1. So what you actually thought, you thought like you will be writing y minus y1, you will get the slope into x minus x1, though it is not like that. It is y minus y1 slope of normal, whatever that is, into x minus x1. Okay. So till now you don't have anything. You don't have x1 y1. You don't have slope of normal. Okay. So now what to do? Listen, x square equals 4y, y equals x square by 4. Differentiate. Dy by dx is 2x by 4, that is x by 2. You are finding this at x1 y1. So it will become x1 by 2. So what about slope of normal? Slope of normal becomes minus 2 by x1. Slope of normal becomes minus 2 by x1. And this minus 2 by x1 can be equated to y1 minus 2 upon x1 minus 1. You know why? Because see, consider this point A and this point B. AB is actually normal only. And on this line, we have 2 points, half 1 comma 2 and x1 y1. So using 2 point form, we can find its slope, which we have already calculated using calculus. Slope of same line, so we will equate. From here, we are getting equation in x1 and y1. And you know what? Also, there is one more equation. X1 square equals 4y1. Why? Point lies on the curve. Now, will we be able to solve this equation? Yes. What we will do? First, let us cross multiply here. Minus 2x1 plus 2 equals x1 y1 minus 2x1. This gets cancelled. So 2 equals x1 y1. You put value of y1 here. X1 square upon 4. So that will give you x1 cube equals 8. Cubic equation, 3 roots, 2 will be non-real. You can check later. Only one real root, 2 will be coming. And if x1 is 2, you can once again put it here so that you get y1 as 1. So in fact, the point of contact is 2 comma 1 and not 1 comma 2. Okay. You have got the point of contact. Now you can use that concept. Equation of normal. Y minus y1. What about slope of normal? See here. You can put this value of x1 as 2 so that you get slope of normal minus 2 by 2 minus 1 into x minus x1. So y minus 1 minus x plus 1, x plus y equals 2. X plus y equals 2. Is it correct? No, wait. Y minus y1 slope x minus x1. It is 2 here. Point of contact. X1 is 2, y1 is 1. So it will become 2. This will give you 3. So x plus y is equal to 3. This will be the answer. That is C option and not A. You will get option A when you will take 1 comma 2 at the place of B. Okay. And that is why it is a good question. This question is from NCERT. So it can be asked in board exams as well. Okay, now this particular question is very important. Here you will actually see what calculus is. Find possible values of P for which the equation find possible values of P for which the equation Px square equals ln x has exactly one solution. So basically we have to find the value of P. P is unknown. You have to find what are those values of P which you put here in this equation will give you exactly one root or exactly one solution or exactly one value of x. Okay. Obviously, you can't find that by hit and try. You don't know what can be the value of P for which these two will be equal or will have one solution, this whole equation. So before actually going into the question, I want to ask you one thing. What will be your approach? How you will find it? What will be your approach towards finding this value of P? How to tackle this question? Because see, they are not asking natural value of P or that so that you can put P as 1, 2, 3 like that. It can be any real number. So forget about hit and trial or something like that. Like suppose if the answer comes in interval, then what? We cannot go on putting the values. So how to start this question? See here, the most important thing is to create the possibilities, or to sorry, not to create, to discuss the possibilities. Discuss the possibilities means you have no idea about P. They want you to find value of P. I don't know what to do here so that it comes out to have exactly one value of X. So if something is not known to us in mathematics, there are three possibilities. It can be 0. So if this value is 0, what happens to this equation? This becomes 0 equals ln x. And ln x equals 0 means log x base is 0. And this is exactly having one value, whose value is also 1. What is the meaning of this whole thing? I had no idea how to start because I have to find the value of P and P is unknown to us. So if something is unknown in mathematics, so there are three possibilities. It can be positive, negative or 0. So I first put P equal to 0 and put it here. I got X as 1, which is a single value. One solution. That means P equal to 0 is totally acceptable. This will be included in the answer. P equal to 0 is going to give me a single solution. Now case 2. Case 2 is if P is negative. If P is negative, now listen carefully. Both the functions are of different nature. In the left hand side we have algebraic function px square. In the right hand side we have logarithmic equation. So basically we are going to tackle this question graphically. Now let us draw a graph of y equals px square and y equals ln x, where you should note that p is taken negative in this case, because this is our assumption that what about p is negative. So what you are going to do, you are going to draw both of them on the same Cartesian plane. Then only you will be able to decide whether how many roots are there. So y equals ln x. This is your graph of y equals ln x. Okay. Now p is negative. P negative means it can be any negative number that you can think, minus 2, minus root 2, minus 1 by 7, minus 1000, whatever. All negative p's are included here. So can you tell me if p is negative, what will be the shape of y equals px square? Yes, anyone? If p is negative, what will be the shape of y equals px square? This is a standard curve, you have already studied about it. What will be the shape? ln x I have drawn. Yes, anyone? Shape of this curve, y equals px square, p is negative. You can put any number in your mind, what any negative integer in place of p, like minus 2. So y equals minus 2x square. What is the shape of this curve? Anyone? If you have anything like this, y equals minus 2x square, you don't know how to draw the graph, or y equals 4x square, y equals x square. You don't know how to draw these graphs. It will be parabola because these were the four standard equations. Y square is equal to 4x, y square equals minus 4x. They are comparable to that. X square is equal to 4ay, x square equals minus 4ay. So our question is like comparable to the last form, and the vertex will be 0 0. What do you observe? This red and blue curve is meeting at one solution. One solution, this point. One solution. So what is the meaning? That means all values of p which are negative. Okay. You draw any you draw this curve y equals px square and take any p minus 2, minus 3, minus 4. It will always give you one solution. One more thing. See, if you draw a graph of y equals minus 2x square, y equal to minus 3x square, all of them will look same. It will depend whether they are shrinking or stretching. This we have discussed in our transformation of graphs class. Okay. So it will not matter whether p is minus 2, minus 3 or any negative number. Ultimately, it's going to cut at only one point. You stretch it to any extent or compress it, ultimately it is going to cut only at one point. Okay, so once again one solution. So till now we have discussed two cases, p equal to 0, p less than 0, and every time I'm getting one solution. That means minus infinity to 0 close, this is the part of the answer. Minus infinity to 0 close, this is the part of the answer. Or p0 is allowed, all negative p's are allowed. Now third case, if p is positive, let us suppose that all positive p's are also the part of the answer. In that case, p belongs to R will be the answer. Why? All negative p's are acceptable, all positive p's are acceptable, 0 is also acceptable, nothing is left. So p belongs to R will be the answer. But let us see if it will happen. Again, draw the two curves. One is your y equals ln x, because ultimately you have to solve this equation only, and for this you draw the two curves y equals px square, y equals ln x. This is your y equals ln x. Now let us draw the graph of y equals px square. See, basically, if you draw now y equals px square, where p is positive, right? It will be like this. See, this will be the shape, mouth opening upward. If you remember, if coefficient of x square is positive, mouth upward. If coefficient of x square negative, mouth downward. Concave upward, concave downward. Vertex is 0 0 here. So actually, if you draw this curve, let me tell you that these curves are not okay. Suppose this is your y equals px square. Then if you draw a curve like this, y equals ln x, it will be intersecting at 2 points. So you will get two values of x, but I want only one value. If you draw graph like this is also not acceptable. They want us to get one solution. We have to find that positive p for which I am getting one solution. Maybe something like this. Maybe something like this. Okay. Maybe something like this. So this point where they are meeting, okay, we have to find this point. Because see, I think it is not possible for all positive p's that they meet at only one point. So we need to find it. Now you must be thinking, where is dy by dx? Because I am telling you about tangent and normal. Until then it is not visible. Now it will come. See, if both of them have one solution, that means there will be a common tangent. Note this thing. There will be a common tangent. And common tangent means common tangent where? At the point of contact. Okay. At the point of contact. So what about this x1, y1? It will satisfy y equals ln x. It will satisfy y equals px square. Okay. And it will satisfy the equation of tangent as well. So let us do one thing. Let us find dy by dx here at x1, y1. 2px at x1, y1. So it will be 2px1. Let us find dy by dx here. at x1 y1. First of all, it will be 1 by x. Then we put x1 y1. So it will be 1 upon x1. Let us equate these two. Why we are equating? Because this is common tangent. Common tangent means it is tangent to both. So obviously, if one line is tangent to both, and we are finding dy by dx from different curves, but they must be equal. Why? Same line is there. So because of this, I get x1 square as 1 by 2p. Okay, now point will satisfy its equation. So I am putting x1 y1 in the equation of parabola. From here I put this value and I got the y coordinate as half. So this point x1 y1, its y coordinate is half. If y coordinate is half, we need to find y coordinate, sorry, x coordinate also. For that we'll put this point in the equation of ln x. Since y1 equals ln x1, let us put it here. Half equals log of x1 base c. So x1 is e to the power half. We have x1, we have y1, but ultimately we have to find p. So what you can do now, you can see, put this value here. So x1 square is e, and p is finally this positive value 1 upon 2e. What is the meaning of this whole discussion? Common tangent, this and that, point satisfying the curves, okay, equating the slopes. To determine the value of p for which this situation is possible. So are all the positive p's satisfying this condition? No. Only one value of p, only one positive value of p is satisfying the condition that both of them are having one solution. Therefore, from cases 1 to 3, from first case you are getting p as 0, from second case you are getting all negative p's, but from the third part you are not getting all positive p's. In fact, you are getting only one value, that is called intersection. Okay. So if you remember, we have discussed this point of all the cases we take union, and within the case we take intersection. So based on that, the answer of this question is all negative p's and 0, and an individual positive value of p, that is 1 upon 2e. What is this e? This is Napier's constant. Its value is roughly 2.7. So that is the final answer. Okay. So a very good question containing multiple concepts, and first of all you need to understand that you have to tackle this question graphically. And another important thing, you are supposed to find the values of p, and you don't know how to start, so you will start making the cases. If p is 0, it became a simple logarithmic equation. I got x as 1 root, so p equal to 0. This is one answer. When I took negative p, I got a parabola opening downward. So in all the cases, whether how much I shrink or stretch this blue curve, it will be meeting this red curve only at one point, which is represented by this green dot. So for all negative p's, you will get a parabola opening downward. They will always cut ln x at one point. So all negative p's are acceptable. But when I was taking this case of p greater than 0, I told you they can cut at 2 point, they may not cut at all, but they are not acceptable. I want one solution. So that will be the case when both of them will be touching each other. If they will be touching each other, they will have a common tangent. Common tangent means its slope will be same whether you find it from parabola or from ln x. So I differentiated both of them and equated. As a result, I got x1 square as 1 by 2p. Now I said you start putting this point in the equation of curves, because this is point of contact, so it will satisfy their equation. Once I got y1 first. Putting y1 value of y1 in any equation, I got x1. And finally, after putting this value here, I got value of one of the only possible value of positive p as 1 by 2. Then last, I will combine all the three, and that will give me the value of p for which the equation has exactly one solution. So very good question from the application of derivative part. Okay. Okay, just I will explain one more little topic here, and today we'll leave it here only. As I say quite often, please go through the notes. They will help you understand everything in a more clear way, because see here I write and I come to the next point. There you will get time to go through each step again and again. Okay. And if you have any problem, you can ask me. See, you will be able to understand it very quickly, because this is related to something that you studied in class 11th, angle between the lines. If you remember this formula, tan theta is mod of m1 minus m2 upon 1 plus m1 m2. This formula was used to find the acute angle between the two lines whose slopes were m1 and m2. And the same heading is there, angle between two intersecting curves. So if the formula is for angle between two lines, why we are using to find the angle between two intersecting curves? Suppose you have this curve y is equal to fx, and you have this curve, the second curve, as y is equal to, let me draw it with different color. Suppose this is another curve y is equal to gx. As you can see, let us say they are meeting at some point. So basically, if someone says this is angle theta, it makes no sense. Why? Angle is always defined between two lines, two curved portions. You cannot say that that is the angle. Okay. See, you always find angle of triangle. What about if someone makes like this? What you will say, this is angle? No, no. Angle is defined between lines. So how come they are finding angle between two intersecting curves? What they will do, first of all, they will find the point of intersection. Okay, they will find the point of intersection, which is, let us suppose x1 y1. This black and green curve for fx or gx, suppose they are meeting at this point x1 y1. Now what they will do, because this is the actual definition, now what they will do, they will draw two tangents to the two curves at this point of intersection. See this red one is tangent to the black curve fx, and blue one will be tangent to the green curve here at this same point. Now we have two lines. So what we have to do? You have two intersecting curves, find their point of intersection. Let us say it is x1 y1. At x1 y1 you will draw two tangents. Okay, two tangents to two different curves. Now tangents are lines. So basically this angle, now see, not angle between curve, actually angle between the tangents is called theta, and this is the same angle here. So basically you have tangents, slope of tangents are differentiations or dy by dx. What is this? F dash g dash. They are derivatives only. So ultimately now this is related to this. So you can remember in one line that angle between two intersecting curves is actually defined as the angle between their tangents drawn at their point of intersection. Okay. No angle between curved portions. In fact, take their point of intersection, draw tangents on them, find angle between them. That is called angle between two curves. Geometry, tan theta mod of m1 minus m2 upon 1 plus m1 m2, and now we are finding slopes by dy by dx. So that is the formula. Lastly, there is something called orthogonal curves. Orthogonal stands for perpendicular. Okay. So write one simple thing. Two curves are orthogonal if angle between them is 90 degree. Okay, I just want to confirm. Am I audible to everyone?
Yes, sir.
Yes, sir.
Is the screen visible? Can you see this thing? Orthogonal curves.
Yes, sir.
All right, just few more minutes. Okay, I will wind up the session. So orthogonal curves are two curves are said to be orthogonal if angle between them is 90 degree at each point of intersection. I will just take two examples to explain this. That will be over. At each point of intersection. This is very, very important. Questions has been asked in exams. I am underlining it again and again. It is not necessary that there is only one point of intersection of two curves. There may be other points of intersection also. So at each point of intersection, you will find angle between the curves. How? Like this. So if at every point of intersection angle is coming 90 degree, then it is okay. Then curves are orthogonal. Like if there are 2 points of intersection, at one point of intersection angle between tangent is 90, and let's say at some other point angle between tangent is 60 degree. Curves are not orthogonal. It is clearly written in the notes. I am explaining also. Let us solve two questions where both of these concepts will be covered.
Excuse me, sir.
Yes.
So the screen is stuck.
That is why I was asking. I thought like I got disconnected maybe. Now it's not moving. Screen is froze, something like that. Because then I will have to connect it once again. Wait a minute.